So our today's experiment is to make a house wiring for a lamp operated from two different positions or two-way switching. Okay. So what is this two-way switch? I have already explained to you in the previous experiment that if we want that the on-off switch, which is connected to a load, especially lamp load, is to be operated at two different positions as per our convenience, then this comes under two-way switching. Okay. For example, I have told you in the previous class that if we are using staircase, then at night, at night we want that the stairs should be illuminated, so it can be switched on from down, and when we reach the destination or the room, it can be switched off from above, and vice versa. When our work is over and we want to again go to downstairs to say have dinner, then we can again switch on the stairs light or lamp from up and switch off from down. Okay, while we reach down from the stairs. Okay, so what we require apparatus which are required are the two-way switch, 6 ampere 250 volts. So 5 ampere switches and 6 ampere switches are the two standards switches which are manufactured by our Indian manufacturers. So 5 ampere or 6 ampere is all the same, and similarly the power switches which we come across, sometimes it is written 15 amperes, sometimes it is written 16 amperes, both are correct. Okay, so we require two-way switches, one MCB double pole throw type, one holder for bulb and bulbs in two quantities, and tester, line tester. Okay, so here 3-pin socket has three types of terminals. One is the neutral, one is the phase, and one is the earthing. Okay, so as I have told you in the previous experiment as well, that the earthing switch size is bigger than the other two, or you can say phase and neutral, and it is above the phase and neutral, so that as and when some short circuit occurs or some fault current is flowing, so it can be passed on to the earth, so that the appliance to which it is connected load can be prevented from any damage. Okay, MCB, you know that normally in house wiring we use two pole MCB, and we know that the fuse and the MCBs are used to isolate the system in case of overload and in case of short circuit. Okay, so what is the difference between the overload and the short circuit? So for example, you can say if a 230-volt supply is there at home, and the appliance which is connected is having some rated capacity. So I was telling that if the rated capacity current is drawn, it's fine, it's good enough, but the overload capacity is also defined for the appliances. It may be say 10 to 15%. Okay, so if the lamp or any other load is drawing 10 to 15% more, it is still okay, because it is within the limits of the overload capacity for which the appliance is tested and manufactured. Okay, but if things goes beyond that, then it is a problem. Okay, say 7 ampere current is there, or 7.5 ampere current is there which is being drawn, then will be categorized under overload, excessive overload, and it is harmful. So in that case, the fuse or the MCBs, whichever is connected to the system, or both may be also connected. Sometimes we see that the fuse, rewirable small fuse, is connected in the switch board, and of course the main switch is having MCBs. So that is the double protection system. And next is the short circuit. Short circuit is nothing but whenever we come across any fault. So the tendency of the current is to follow the least resistive path. So whenever the fault occurs, so there is creation of a path of less resistance than as desired by the load. So the current will follow that least resistive path or short circuit path. So the excessive current may flow. So to prevent that excessive current flow or damage, MCBs and fuse comes into the action. Okay. And everything is provided for the safety of both human beings and equipments we have just mentioned. Okay. So this is the circuit diagram of the staircase winding or wiring. So S1 and S2 are two switches, SPDT switches, single pole double throw type switches are there. So you can say one is connected upstairs and one is connected downstairs. And when the circuit is complete, the lamp will glow, and when it is not complete, it will be in off state. Okay, but we have the provision to switch on from downstairs as well as from upstairs. So in the theory and the procedure, we will come across this, and I will then explain a bit more about it. So these are just the phase and the neutral wire which are connected to the switches, which are connected to the lamps. Okay, this is the lamp which is glowing. Okay, so it is that wiring which makes the two-way switches to operate a bulb, one at the beginning of the stairs and other at the end. One of the terminals of the bulb is connected to the neutral and other is connected to the middle slot of the two-way switch. Okay, so phase connection is with the middle slot. Okay, in our normal switches, what happens? There is two slots, phase and neutral, to which the wires is connected to, and the other end is connected to the load. But in the two-way switches, this phase wire is connected to the middle slot of the two-way switch. So we have three slots. Okay, in normal switch on off switch, you have only two slot, one on off switch, one is on, another is off. But in this two-way switch, the middle slot is also there. Okay, so what is the procedure to operate and to check? Plan the wiring and the casing into the circuit diagram, and with the help of the pliers and strippers, then connect the phase wire to the central pin of the two-way switch and connect the remaining ends A and B to the corresponding A and B of the two-way switch. Okay, since we are having two switches, so A and B connections or the slots are to be connected to each other, and connect the central pin to the lamp. Okay, one central switch or the central slot is to be connected to the phase wire, and other is to be connected to the lamp load. Okay, so which is other, which is also connected to the neutral, the other end. Now switch on and off the two switches alternative to check the supply of the bulb. Okay, we will now check how this lamp will glow and when it will not glow. So what are the precautions which are to be taken here? That there should not be any loose connection. Do not touch any non-insulated wire. Okay, loose connections means that if the wires are not inserted in the slot properly, then this is what we mean by loose connection. And do not touch the non-insulated wire. Since we have used our pliers and stripper to peel off the end of the wire, so when we peel off, then the PVC cable is peeled off. Okay, so the peeled off portion gives us the copper conductor in which the current is flowing. If it is flowing the desired path or the desired conductors or the when it is connected to the load, then it is fine, good enough. But if we touch this non-insulated wire, then current will flow through us, so that is harmful. Okay, and do not keep any joint open, that wire should not be kept in open, that if by mistake someone might touch, and we should use MCB of proper MCB and switches of proper ratings. Okay, because we are, if we are provided with the MCBs of required capacity, if we are not using of the required, it will not sense, because let us suppose that we are having the MCB of 8 amperes, okay, for the 6 ampere switch. So it means that it might, or 7 ampere, there are standards of MCBs available. So if the current is beyond 8 amperes, then it will sense that some fault is there or some overload is there, then it will trip off. But if we are connecting, say, 25 ampere MCB to the 6 ampere load, then it is of no use, because it can detect the fault current only if it is beyond 25 amperes. It will not detect the overload currents or the excessive overload current. So if we are connecting this S1 middle slot to A and A slots to the middle slot of S2, then this circuit is complete. So the lamp will glow. Okay. So in this way, we can say that we have reached above. Now, when we have reached above, then what we will do? We will switch off. So we will do like this. Okay. We will press the middle slot to B position. Okay. So now the lamp will not glow because the circuit is not complete. Okay. So we will work upstairs, and after our work is complete, we will switch on the bulb again. Okay. So while we switch on the bulb again, we will now connect this to A again. Now again the circuit is complete. So lamp will glow and we will reach down. So when we reach down, we are required to switch off. So we will connect the middle slot to B position. Okay. Okay. So this is the process, and its vice versa is also true. For example, if we have begun with a position that B is connected to the S2 and we have connected B position. So now again the circuit is complete. We go above or upstairs, switch off the circuit, and when our work is complete, we again switch on the bulb and we go down, and when we go down, we can again switch off. Okay, so these two are the common ways, and the diagram which is shown is both side open. Okay, but this is not the case. In actual, one will be connected to the phase. Okay, because if both sides are open simultaneously, it is not possible. Okay, it has to be connected to the phase. Okay, so if the both sides are open, either we are at downstairs or we are at upstairs. So if we are at down, then best what we can do, we can connect it to A or B, only one. Okay, let us say that we have connected to A, but again now this circuit is not completed because it is open from the other end. So when it is open from other end, the circuit is incomplete and lamp will not glow. So our purpose will not be solved. Okay, so is this clear now?
Yes, sir.